students, let us discuss the properties of colloids. In this video, we will be going to discuss on an important optical property of colloids, that is Tyndall effect. Tyndall effect. You are familiar with this word Tyndall effect? Let us discuss in detail. When a strong beam of light is made to pass through a true solution, in the first figure we have true solution. When a strong beam of light is passed through it, it is observed that the path of the light does not become visible in the case of true solution. But same if we do with the colloidal solution, which is heterogeneous in nature, it is observed that the path of the light become visible. You can see the path of the light is visible, and when it is viewed from the direction at the right angle to that of the incident beam. So when you view from this one, we will be getting we can observe the path of it. A bluish light, it get illuminated by a bluish light. This effect is called as Tyndall effect because this effect was first observed by Faraday, but later the studies has done by John Tindal. Therefore, this effect is termed as Tyndall effect. So we can say when a beam of a light is passed through a colloidal solution, then the path of the beam is illuminated by a bluish light due to the scattering of light by the colloidal particles. This effect is called as Tyndall effect. So we can say that why it happens, because the particles present in the colloidal solution are actually scattering the light, and because of this we can able to view the path of it. And the bright cone of the light which is observed here, this cone is called as Tyndall cone. Maybe you have seen such views, maybe in the real life or in the television. This is actually, you can able to view such when a beam of sunlight enters a dark room through a slit. At the time also we will be getting this type of view. Here it is shown how the scattering of light is taking place and how this path is visible now when the light is made to pass through colloidal solution. This is quite familiar to you. Did you have noticed in the cinema hall during the projection of picture, at the time you can able to view the path of the light, and that is actually due to the scattering of light by the dust particles present in the air. That means the dust particle in the air are actually scattering the light, which act as a colloidal particles. It scatters the light. Because of this only we can able to view the path of the light. Tyndall effect is observed only in following condition. The first condition, the diameter of the dispersed particles is not much smaller than the wavelength of the light used. Second one, the refractive indices of the dispersed phase and the dispersion medium differs greatly in magnitude. So this is all about the Tyndall effect, which is a very important property of colloids, and this property will explain the heterogeneous nature of the colloids. So the next property we'll be discussing in the next video. So thank you everyone.